Good morning. Welcome to Algebra 2. We're looking at 10.4. Our lesson is on ellipses. Now, those of you who were at an AP test today and missed class, we have two homework assignments due on Friday. 10.3b is a paper submission. The handout's on Academy Central. Just download that. The solutions are there also. It's a challenge assignment. And also assignment 10.4 is a paper submission due tomorrow. If you're absent, the PDF of the homework is right there online, so you can download that. Now, for our warm-up activity, go ahead and let's review. Classify each one of these as either parabola, that's if it's only one square term, ellipse, circle, or hyperbola. This is a warm-up activity. You may begin. Pause the camera here until we're done. Okay, unpause. So what we've looked at so far is that the parabolas are the conics that have only one square term. If there's 0 square terms, that's a good indication it's a line. There were two hyperbolas, 5 and 7. Then up here, what we're looking for, if you have the same sign, S-I-G-N sign, same sign and same coefficient, that's the indication you have a circle. And the other two are same signs, meaning they're both positive, but the coefficients are not the same. 25 is not the same as 4. That means we have an ellipse. So this is just good to keep this fresh in our minds so that when you get to the test, you'll be able to do it in a flash. Any questions on 1 through 7? Yeah, Andrew.
I have a question. When's the test going to be?
Test is block day of next week.
Okay.
Further questions? Unit 10 test, block day of next week.
Wait, how is number 1 an ellipse if it has same sign, different coefficients, but then it's also...
Well, when we're talking about, okay, so the question is, how do we know number 1 is an ellipse?
No, that's not the question.
Oh, okay.
I wasn't done. And then number 3, it's also a ellipse, but it has different signs.
Okay, so we have a standard for categorizing equations as an ellipse. First of all, you ignore all the terms except for the square terms. So let's take a look only at the square terms. If those terms have the same sign and the same coefficient, then it's a circle. We're ignoring the other terms. If they have the same sign with different coefficients, and that's the case here. For number 1, we have the same sign, but the coefficients 25 and 4 are different. So ignoring everything else, that's how we know it's an ellipse. So that way you don't have to be distracted by the
But there's
minuses.
different signs on 3. It's plus, minus.
No, it's plus plus. Because the first square term is positive, and the second square term is positive. That minus sign here in number 3 can be thought of as plus, negative. So it's really, that -6 is an indication that this linear term is negative, but we don't pay attention to the linear terms when categorizing an equation that's in the conic form. We pay attention only to the quadratic coefficients, so that one you can ignore. Further questions? All right, now the new material, that was review. The new material is ellipses. Now, let's take a look at the standard form of an ellipse. It's x minus h squared over a squared plus y minus k squared over b squared is equal to 1. It's never another number, it's always the number 1. Let's find out what this means. Let's get a picture that goes alongside this. Now, the picture that I'd like you to draw, it's actually a couple. I'd like you to draw an ellipse centered at the origin. So it looks like an oval. The x-intercepts are at plus or minus a, and the y-intercepts are at plus or minus b. Now, in many ways, this behaves just like a circle, but the radius changes as you go around. Here, check this out. I'm going to demonstrate for you what's happening with, oh, see that? It's going around, but it's centered at the origin. I want it to be centered on the right. So when you go into the active inspire preferences, go down to tools, and notice it's center. No, I want to go top left. So that now, check this out. Get ready for some eye candy. We're just gonna go around and we'll actually make it thicker so it's even yummier. We've got, it's like a circle, but the radius starts out at A, then it shrinks down to B, then it gets longer again, comes out to A. So it's not like a circle where it's the same radius going all the way around. If it were A the whole time, if the radius were A all the way around, it would look like this. But no, it's like the radius shrinks from A down to B. Then the radius gets longer, goes back up to A, shrinks back to B, gets longer to A. So, that's why, in this example that we have, we can say that the center of the ellipse is at 2, 1. Record the center as h, k, which is 2, 1, and then let's note that the value of a, which is the radius in the x direction, is 3. It's always the square root of the number in the denominator under x minus h squared, and the radius in the other direction is 2. Now, this is a ellipse centered at the origin. Let's add an ellipse to this picture. Let's put an ellipse centered at h, k, and it has a radius of a in the xy direction, in the left to right direction, but the radius in the other direction is b. So you get that dynamic again. And even more eye candy. This is vegan eye candy, so don't panic. It goes from A, it's like we're going around, the radius shrinks down to B, then it gets to A again, shrinks down to B. This is how you make an ellipse. You have 2 radii. You have a radius in the xy direction, in the horizontal direction, and a radius in the vertical direction. So how do we sketch an ellipse? These things go super quick. I think you'll enjoy it. Students have given this lesson rave reviews. In fact, there was a student who's really struggling. First period said, wow, this is fun when you understand it. Because really all you have to do is, once you get the center, all you have to do is plot the point 2, 1, and then since a is equal to 3, we're going to go left and right 3 units, so 1, 2, 3 to the right, 1, 2, 3 to the left. But we're not going 3 up and down, we're only going 2 up and down, so go from the center, go up 2 and down 2. And then, the final step is the most fun. It's where you select your ellipse tool, put the stylus at the center, and oh, now I want it to actually be centered this time. That was a terribly embarrassing mistake. I'm going to go back to preferences and change this to center, because I want to start from the center of my ellipse. And check it out. 3, 2, 1.
Oh.
Yeah, okay. People are going to love this one. Maybe I didn't hit done. I'll bet that's it. I didn't hit done because I wanted to go center. Yep, that was my big mistake. I didn't click done. So now when I go here, go, ooh, there's an ellipse. Let's erase the one that didn't work. So, do you have any questions as to how it is you can get the graph of an ellipse? It looks like a circle, except it doesn't have the same radius horizontally as it does vertically. Hey, give this one a try. Try to sketch the graph of the ellipse that's in the lower right-hand corner. By the way, what center are you using for this ellipse, Gerald?
-3, -1.
-3, -1 is the correct center. And what are you going to be using for the value of A? Let's go to someone else on this. Can you help me please, J?
Do you go 4?
Well, B is going to equal 4, but A comes from the denominator over here. What's the square root of 1?
1.
Yeah, so we're going to go left and right 1 unit from the center, but we're going to go up and down 4 units from the center. So try that. try to get your ellipse. And then go and select the ellipse tool. Go to your color palette, select red, and then place your stylus on the center of the ellipse. Go ooh and ah. Ooh. There it is. There's the ellipse. The radius horizontally is 1. Vertically, it's 4. Any questions on this? All right, we're moving. We're moving now. We've gotten past the preferences snafu. And we're on the back side. Now, this one is going to lean heavily on the lessons that you learned from your greatest teacher earlier in class. Not me. You know the name of your greatest teacher. You made some mistakes. Mistakes
Jesus
can be a great teacher.
did not make mistakes.
Jesus is your greatest teacher. But so
He did not make mistakes.
when quoting The Last Jedi, yeah, it was Yoda who said that failure is the greatest teacher, but he was wrong. It's actually Jesus is our greatest teacher. So thank you, Gerald, for pointing that out. But maybe your second greatest teacher were some of the mistakes that you made when playing the hot dog activity. So we're going to capitalize on the reason that the recent learning that you did in the hot dog game. And let's rewrite problem number 1 as 25x squared plus 100x plus 4y squared minus 8y equals -4. You see all I did there was I rearranged the terms so that the x's are next to each other and the y's are next to each other. So this is the original equation, and I really just used the commutative property of addition. I just changed the order. So basically I rearranged the terms. We've never had that code before. Rearrange. That's all we did. It's no big deal. Okay, so now we're going to set up the 3 boxes for x. So draw 3 boxes for x, and then go to your color palette and select orange, because you need your 3 orange boxes to complete the square in y. But you gotta be super careful. Here we go. Here's the super careful portion of the lesson where you can really learn the mistakes from your second greatest teacher. It really show that you've learned from your second greatest teacher by factoring a 25 out of the x terms. That will leave us x squared plus something, x plus something. Factor a 4 out of the first 2 y terms to give you 4 times the quantity y squared minus 2y plus something equals -4 plus blank plus blank. Now, let's populate the triplet of green boxes with 3 things. What are they called? Oh yeah, numbers. What are the 3 numbers that would populate the triplet of green boxes? Is there a volunteer who thinks you know? You can give me. Oh, hold on. Whoa, we haven't filled in this number yet. Can someone tell me what number goes right there? Factoring the 25 out of the first 2 x terms. What is it? Yeah, Jack. 4. Yeah, it's got to be a 4. So that means that the first number in the first green box is 4. Cut it in half and square it, you got 4, 2, 4. So that means the number that completes the square is 4. Who can tell me what number would go over here to counterbalance the effect of placing a 4? Hold on. You change that to green. No, change it to blue. Okay, so this green 4 right here changes the problem. It throws it off balance. So what number should I put here to bring the equation back into balance? I'll take a volunteer on this one. Maybe you think you see it. Maybe you think you know what's going on. All right, go ahead and collaborate with someone then. Tell your fellow group members what number goes right here to counterbalance this 4.
-4. Uh-oh.
Volunteer to tell me.
And same thing.
All right, Daniel, what'd you get for this one?
-100.
Negative 100 would be correct if it were on the same side as the positive 100, but this is the other side of the equal sign. So get this, it's like we've added 100 to the, from your perspective, that's the left-hand side of the equation. So we want to add something to the other side of the equation to balance it out. So if you added 100 on the left-hand side of the equation,
So -100.
the boundary between the two sides is the equal sign. So we added 100 to the left, so what number would I add to the right?
Oh, -96.
No, positive 100. Because it's gotta be positive 100. Out of curiosity, how many of you added, I'm gonna write it sideways so it shows up. How many of you added 100 to the right-hand side to balance out the 100 that you added to the left-hand side? A few of you did, that's great. You know what's going on here? You can add 100 and then add negative 100 to the left side, or that's adding two numbers to the same side to keep it balanced. Or you can add 100 on the left and add 100 on the right. That's another way to balance it. So it's a slightly different balancing strategy than what we did earlier in class, when we added a number to one side of the equation and added the opposite of that number to the same side. Here, we're just going to add the same number to both sides. So what are the three numbers that populate the orange boxes? Help me out with that one, please, Gerald.
-2.
-2.
-1.
And?
1.
Yeah, so if I put a 1 on the left-hand side of the equation, what number will balance it over on the right-hand side of the equation? Raise your hand if you think you know. Right. Let's go to Mia. This one, Mia. 4 is Mia's answer. Raise your hand if you agree with 4. She thinks if I put a 4 here, that'll balance out the 1. Raise your hand if you disagree. Raise your hand if, to be honest, you're just not sure. Which category are you in, Mason? Agree, disagree, or not sure?
Sorry.
So what Mia did was she put a 1 right here to complete the square. Why? Because that's the third orange box. So the third box is what completes the square. So I asked her what number will balance the equation, because she changed it. She added a 1 here that wasn't there before. So she said a 4 would balance it out. Do you agree, disagree, or not sure?
Agree.
Okay, so you agree. Andrew, where are you at? Agree, disagree, or not sure?
Agree.
Raise your hand if you agree with the 4. She thinks it's 4. Jay, are you agree, disagree, or not sure?
Agree.
Agree. All right, so it looks like everyone agrees. Well, it turns out that that's correct. That is the correct number there. So we're going to factor this then as 25 times something squared plus 4 times something squared equals 100, because -4 plus 4 plus 100 simplifies to 100. All right, so go ahead and use the factoring process to fill in those parentheses with the factored version of the trinomials above. Jack, what factored version did you get for this one?
I said x plus 2.
You said x plus 2 squared is the same thing as x squared plus 4, which is correct. And let's go to Alana. What's your factored version of the trinomial above? Always look at box 2. In fact, I would put a fireworks explosion symbol on box 2, the middle box for the greens and for the oranges, because that's always the box that will tell you what the factored form is. I mean, do you believe that y minus 1 times y minus 1, when you FOIL it out, would give you y squared minus 2y plus 1? Yeah, it's always going to be box 2. See, that's another reason we take the time to write out the 3 boxes. At the end of class on Wednesday, at the end of class on Tuesday, a student was walking out of class, and I noticed that she had never done the 3 boxes before, but then on Tuesday she was doing the 3 boxes, and I said, oh, you're doing the 3 boxes. And her response to me was this. I won't forget this for a long time. She said, yeah, they actually work. No, she said this. Yeah, they actually help. I was blown away. Here's a student who actually believes that the 3 boxes are helpful. You don't hear this every day. But you might find this to be the case also. When you're struggling to factor a trinomial after having completed it with the 3-box method, you also might find that the 3 boxes actually help. And you might be the next person who's walking out of class saying, with the voice of embarrassed exasperation, yeah, they actually help. Does anyone have any questions on how to factor using box 2? Okay, box 2. There are students out there who believe it actually helps. I know, weird. It's not easy to believe. We need the number 1 here. We don't have the number 1, so we've got to divide by 100. Can't deal with this ellipse equation unless we got the number 1 here. Easiest way to get the number 1 is to divide all 3 terms by 100. Yeah. Okay, so here we go. Can someone anticipate what the reduced fraction will be? Instead of me actually writing 25 over 100, to what does the fraction 25 100ths reduce? Class, let's call it out. Talk to me. All right, Alana, you can say it. I heard you whisper
25
it.
goes into 100 4 times.
Yeah, so it's just going to be x plus 2 squared over 4. Go ahead and try this one. When you divide this term by 100, anticipate what the reduced version of the fraction will be. So it's going to be y minus 1 squared over what, class? Gerald, do you know? If I divide this term by 100, then when you cancel the 4 and the 100 cancel, what's going to be left in the denominator?
Oh gosh, I could be so wrong. I would say 25.
25 is correct. So now we're in a position where we can sketch the center, or sketch the ellipse based on the center, A and B. It's clear now that the center is at negative 2 comma 1, an A value of 2 and a B value of 5. Go ahead and sketch the graph of the ellipse. A is equal to 2, B is equal to 1, 2, 3, 4, 5. Yeah, so I guess it's not exactly drawn to scale, but there it is. If you did it correctly, you should have a point on the ellipse at 0, comma 1, at negative 2, comma 6, negative 4, comma 1, and negative 2, comma negative 4. Do you have any questions on that one? Okay, now I'd like all of you to try number 2 on your own. This will be a practice problem for you. Try number 2. I'm going to pause the camera, and then when you're done, we'll go over it. So try number 2 on your own. Okay, friends, we're back. We're going to go over problem 2. What we've done so far is we've collected x squared and negative 6x. From the y terms, I factored out 4 to get y squared plus 6y plus blank. I hope that for the 3 green boxes to complete the square in x, you use negative 6, negative 3, and 9. Fireworks explosion symbol on the middle box here. To complete the square in y, what was the triplet of boxes that you used here? Daniel?
6, 3, 9.
With boom, explosion on the 3. So these are the ones we're going to use later when we factor. But yeah, good job on that. So we're going to complete the square in x with 9. Just add 9 to the other side. Now it's balanced. And we also use a 9 here, but this one's a little bit different because it's a little more complicated. What did you use on the right-hand side to balance out this 9 on the left? What did you use? Jack?
36.
Nice. 36 is the right number to use. Any questions on why 36 is the number that will balance that one? Now's a good time to ask if you didn't have 36. Okay, so now the factored versions of these, this is going to be x minus 3 squared. This is 4 times y plus 3 squared. And this is going to be, let's see, that's 10. So 46 minus 42 is 4. So dividing both sides by 4 gives me x minus 3 squared over 4 plus y plus 3 squared equals 1. We've got an ellipse with a center at 3 comma negative 3 A is equal to 2, B is equal to 1. So I hope your ellipse is centered at 3 comma negative 3 with an A value of 2, so go left and right 2, a B value of 1, and in red the ellipse looks kind of like that. Any questions on number 2? Okay, you've got about 10 minutes to work on the homework, and you may begin. 10.4 is the homework due on Friday. Enjoy the rest of your afternoon.